You've already had an intro to the law of two, the law of four, and the law of three, and they do actually go in that order. You think it goes two, three, four, but it's actually four, three. Who can remember this from, I think it was last week or the week before? Hot, cold, wet, dry. Eh? You've seen this before, right? This is the way the law of four works. The law of four is really a duplicate of the law of two with one vector shifted. All right. One intact, one shifted, I think is what it, or one split. One split, one intact. This is the way the Journey, I think volume 1 puts it when it talks about the law of two. Yeah, the 7 levels of the law of two. What's meant by that is if you set out and you start walking west, at what point in time will you end up east? At what point in time will you end up walking east? It's a better way to say that.
You won't.
Never, right?
Yeah.
You'll never end up walking east because you're continuing to walk west. That's the vector that's intact, always intact in that way. The one that's split is if you start walking north, eventually you'll end up walking south.
Yeah.
Okay, that's the one that's split. All right, so you've got this, you've got hot, cold. That's one bar, and hot and cold is really what? It's just a measure of how much kinetic energy is in something. Yes, if something is hot, it's really moving. Yeah, it's moving inside. Like, you understand, right? The molecules are all kind of vibrating inside. If something's cold, they're not. Absolute zero, I think, is the point when everything stops moving except for the electrons and whatnot. But the molecules are not bumping up against each other at that point. So this is a measure of how much energy, and realize that it's a scale. You can have something here, you can have something here, 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 anywhere along this bar. All right. Wet and dry is really it's a measure of whether something shears or conforms, I think would be the right way to say it. Yeah. If I pour a glass, or if I pour water into a glass, all right, it's going to conform to the glass, isn't it? If I take this same amount of water and freeze it into a brick and then try and shove it into the glass, well, the glass is probably going to shear, but you get the idea that in order to get it all into the glass, if it's not that exact shape, then I'm going to have to break it. I'm going to have to shear it. I'm going to have to, crack it up until it fits in there. That would be the definition of wet and dry. It's not necessarily whether it's water, it's how conformable it is. It's whether or not it has to shear if it's dry, because you can say ice is dry in this context because it would have to shear, you see, to get in there. Water is wet. Okay, so it's conformability. Now you've got two aspects of the law of two intersecting one another that looks like the law of four. Looks like the law of four. What I mean is fire. Let's do it this way. Get you used to it. Fire is the hot and dry vector, the middle of the hot and dry. Okay? Cold and dry is what? Who knows that symbol now? That's right there.
Earth.
Anyway. Earth, yeah.
Earth.
Yeah, cold and dry. Cold and wet. Water. And warm and hot. Air. Okay? That's why I say they appear this way, because their most fundamental aspects is whether it's hot, cold, wet, or dry. You with me so far?
Yes.
Okay, right. They sit in the middle. They sit in the middle here. And you'll notice that in the upper half, you've got the upward pointing triangles. And then in the lower half, you've got the downward pointing triangles. All right. And they're each opposite each other. So you've
Yeah.
got fire and water. This is why fire and water appear to be completely opposite. And earth and air, will get into why they are opposite, but this is why they appear to be opposite. This is the idea that you've heard of before of apparent opposites versus adjacents. Something that's adjacent. Okay,
Hmm.
this solves that mystery a bit.